Lesson 11-3 is on multiplying rational expressions. Recall that rational expressions are basically just fractions that have polynomials in the numerator and possibly in the denominator. And that to multiply fractions, we multiply the numerators across the top and multiply the denominators across the bottom. A few things to remember when you're multiplying rational expressions is you always want to factor first. Then you can multiply, and if possible, then you want to cancel. So let's take a look at a couple examples here. So we want to find each product. We'll be multiplying these fractions. First example, 5x cubed y over x to the fourth y times xy cubed z squared over 10 xz to the fourth. Now it is possible to do some canceling within each fraction. I think it's a little bit simpler just to kind of combine everything across the top and everything across the bottom. So multiplying across the top, we have 5, and it's an x to the fourth, an x to the third, plus an x to the 1, and then y z squared. Oh, I'm sorry, that should be a y to the fourth. Z squared over 10 x to the fifth, y z to the fourth. And now we can do some canceling. I'm going to look at the numbers, the x's, the y's, and the z's separately. So 5 over 10 leaves me with a 2 on the bottom. X to the fourth over x to the fifth leaves me with 1x on the bottom. Y to the fourth over y leaves me with a y cubed on top. And z squared over z to the fourth leaves me with a z squared on the bottom. So there's my final answer. Second example, x plus 3 over x times 5 over x squared plus 7x plus 12. Well, the first thing that jumps out at me is the denominator of my second fraction is a trinomial that can be factored. So I'm going to write it like this, multiplying across the top. I have 5 times x plus 3. Don't distribute that. Leave it factored, because remember, you can only cancel stuff that's been factored. And on the bottom, I have the x for my first fraction, and my trinomial factors into x plus 3, x plus 4. Now I can cancel out factors that are the same on the top and on the bottom. So the x minus 3's will cancel, and there really isn't anything else. So I'm left with 5 over x times x plus 4. You can leave the denominator in factored form, or you can go ahead and distribute that if you prefer. Here's a third example. X squared minus 3x minus 4 over x plus 5 times x plus 5 over x squared minus 4x. Okay, I'm noticing a trinomial in the top of my first fraction that needs to be factored, and so that will factor into an x minus 4, x plus 1, and then the binomial for my second fraction is an x plus 5. The denominator of my first fraction is x plus 5. And for my second denominator, that's not a trinomial, but I am noticing that there's a greatest common factor of x that I will cancel out. Factor out, and that will leave me with an x minus 4. Now I can cancel factors that are the same on the top as they are on the bottom, like the x minus 4's. The x minus 5's will cancel, and I'm left with x plus 1 over x. Do not cancel those x's. You can't do that because the x on top is having 1 added to it. If the x on top were being multiplied by something, then you could cancel, but you can't do that with addition and subtraction. So there's my final answer. Another example, x squared minus 16 over x plus 4 times x plus 2 over x squared minus 8x plus 16. Okay, the numerator of my first fraction is a difference of squares, which factors into x plus 4, x minus 4. And my second fraction has a numerator that's just a binomial. And then on the bottom, I have an x plus 4. And my second trinomial, the denominator of my second fraction is a trinomial, which is indeed a perfect square trinomial that will factor into x minus 4 squared, or if you want to write it as x minus 4 times x minus 4, it'll be a little easier to see when we start canceling things. Okay, so I have an x plus 4 on the top and an x plus 4 on the bottom. I have an x minus 4 on the top and an x minus 4 on the bottom, and nothing else left. So I have x plus 2 over x minus 4. Do not cancel the x's. Do not reduce the 2 and the 4. That's addition and subtraction, and you can only cancel stuff that's being multiplied.